Welcome to The Explainer. Today, we are jumping into a really fundamental debate that completely changed how we think about the way our bodies fight off disease. This is a story of two totally different ideas, and it pitted two major fields of science against each other, all to solve one great big mystery in our immune system. So here's the central puzzle that had scientists scratching their heads for decades. Think about it. Your immune system has this insane ability to make a specific weapon, an antibody, for pretty much any invader you can imagine. But how? How does it do that? Does it just learn on the fly? Or is something else, something way more surprising going on? Well, to get to the bottom of this, two radically different theories popped up. And we're not talking about a small disagreement here. This was a huge philosophical divide that started a long, long debate, mostly between the chemists on one side and the biologists on the other. Each side had a completely different vision for how we build our immune arsenal. Okay, so on one side, you've got the instruction theory. The easy way to think about this is made to order. It feels pretty intuitive, right? And on the other side, you have the selection theory, which is much more of a ready-to-wear model, a bit more out there. So let's dive into that first idea. For years, the theory that really dominated came from the chemists, and it was championed by, of all people, Linus Pauling. I mean, one of the greatest scientific minds of the entire 20th century. His idea was elegant, it was logical, and it just seemed to make perfect sense. So Pauling's theory, which he published back in 1940, basically said that an antibody starts out as this generic, kind of floppy protein. Then, when an invader, an antigen, shows up, this protein literally uses it as a mold and just folds itself into the perfect shape to match it. It's like a master tailor making a custom suit for a brand new customer. The process was thought to be really simple. Step 1, the antigen shows up. Step 2, a general-purpose protein takes its measurements. And finally, Step 3, a perfectly custom-fit antibody is made, just for that invader. It's simple, efficient, direct. And for a good while, this was the explanation everyone accepted. But you know how it goes. Like in any good story, some puzzling clues started to pop up. There were these key things about how our immune system actually works that this neat and tidy Taylor theory just couldn't explain. The model was starting to show some serious cracks. Yeah, the theory just couldn't explain some really critical stuff. Like, if every antibody is made to order, why on earth would the body remember a past infection and respond way faster the second time around? How does it know not to make tailor-made antibodies against your own cells? And here's a big one. How could you produce billions of antibodies when you supposedly need the original antigen as a template every single time? These were major, major plot holes. So all of this opened the door for a counterproposal, a totally different way of looking at the problem that came from the biologists. People like Niels Jern and Macfarlane Burnet, they came along and basically turned the whole idea on its head. Instead of a tailor shop making one suit at a time, the biologists said, no. Think of the immune system like a massive shopping mall. A mall that's already stocked with millions of different shirts in every possible size, color, and style you could ever imagine. The right one is already there, you just have to find it. The process here is completely different. Your body already has this huge library of immune cells, and each one is displaying one single, unique type of antibody. So when an invader gets in, it's like a shopper just wandering through the mall, bumping into things, until it finds the one shirt that fits perfectly. That moment doesn't create anything new, it just selects the cell that's already there and tells it to start making millions of copies of itself. This new shopping mall model, it was a total game changer. All of a sudden, it could explain all those mysteries the old theory couldn't touch. The evidence just started piling up, and the case was definitely heading towards a final verdict in this great scientific debate. Now, the winning theory didn't just appear overnight. It really evolved over almost 2 decades. It started with Jern's first inkling of the idea in '55, which then got linked to the concept of cell selection by Talmage, and then was finally put all together into one amazing theory by Burnet in 1959. And this final, polished idea became known as the clonal selection theory. It's a concept so powerful and so good at explaining things that it's still the absolute bedrock of how we understand the immune system today. It's all about selection and then cloning. So when you put them side by side, the result is crystal clear. Immune memory, the Taylor model couldn't explain it. The Mall model solved. It creates a reserve of memory cells. What about self-tolerance? Solved. Cells that react to your own body get destroyed early on. The origin of all this diversity? Solved again. It's pre-programmed in the genes of millions of different cells. The selection theory it answered every single question. And with that, the debate was settled. Selection, not instruction, is how our immunity is built. But this was way more than just one theory winning out. It was a huge paradigm shift. It showed that the immune system doesn't really learn in the moment. Instead, it works on this much grander principle. First, you generate incredible diversity, and then you let the environment select what works. So, the big takeaway here is this incredibly powerful idea of selection over instruction. It's almost like Darwin's theory of natural selection, but playing out on a microscopic scale inside our own bodies every single day. And that leaves us with a final thought. Where else in the huge world of biology does this same fundamental principle, generate first, then select, hold true?